Then next, we will start with our first presenter, Bertrand Denis, Head of Meteorological, Geospatial and Open Data System. Please. At the Canadian Centre for Meteorological and Environmental Prediction, he will present an overview of the MSC, its data and area of application, current and future issues. Let me open. Voilà, c'est important de parler dans le micro pour les... Oui, les deux, c'est la même chose.
OK. Merci, Miguel. Thank you, Miguel. So, first of all, for me, it's a dream that is being realized today. So, c'est un rêve qui se réalise aujourd'hui pour moi et pour certains de mes collègues. Alors, bienvenue. So, let's go and let's start. So, my presentation will talk about the Meteorological Service of Canada and also about data, the monitoring, prediction information cycle, and challenges and emerging trends. So, first of all, why weather and climate information matters? Well, simply because most of our social and economic activities are impacted by the weather, climate, water, air quality, and environmental conditions. So safety, disaster risk reduction is impacted, health, water management, energy, transportation, tourism, retailing, insurance. I'm sure you know all about that, but it's good to remember that everywhere the weather has an impact. So what is the mandate of the Meteorological Service of Canada, the MSC? Well, it's to equip the Canadians with information on changing weather, climate, water, and environmental conditions that impacts their health, safety, and economic prosperity. So the MSC is the only Canadian official source of weather warnings. We produce 1.5 million weather forecasts per year, 15,000 severe weather warnings, 500,000 aviation forecasts, 200 marine and ice and sea state forecasts per year. Every day, we collect billions of observations. They come from radar, satellite, surface stations, aircraft, buoys, and so on. So at the center of that, to process all those data, there's the Canadian Meteorological Centre located in Dorval on the Montreal Island, in the West Island. So all the data goes to the CMC, Canadian Meteorological Centre, the CMC. It is processed there. There's not only supercomputer there. There's the people, okay? So we have the research people to support the science. We have also for the IMIT infrastructure Short Services Canada, and also the corporate services. So the data comes from the left, goes to that center, where we run the weather models, and then it is disseminated to partners, the public, and to some of you that are using our data. So let's talk about the data cycle. So we start by observing, monitoring the current state of the environment, so the atmosphere, the ocean, sea ice, air quality, water level, water flow, and so on. So each day we acquire about 10 billion of observation, okay? These are transmitted to our center, and we do quality control on them, and then we ingest in our weather and climate models about 13 million observations per day. So we run on our supercomputers those numerical models to produce the weather forecast, but not only the weather forecast, the climate forecast, the hydrological forecast, and so on. So each day we produce about 40 terabytes of raw data from the model outputs, okay? Then those data are used to make the weather forecasts that are sent to our regional center, where meteorologists can have a look to them and add values and issue warnings, for example, okay? An important part of this cycle is the verification, the performance measurement. So what we do is we measure how good we are, and each year we improve our system and we measure how better we become, okay? So evaluating our performance is part of that cycle. It's very important. So every month, there's about 300 million raw data files downloaded by users, okay? And 150 million geospatial web services requests per month. You'll hear about that from the other talks later on. Challenges and emerging trends. One of the most challenging fact is that over the years, there has been explosion of numerical output data. The volume is exploding. And this is because there's an ever increasing spatial resolution. So our models provide you more and more fine details, but that takes a lot of bytes, okay? So that's one of the most important part of the increasing volume of data. And we have more and more different model configurations. 20 years ago, we had a global model and a regional model for North America. But now we have national models, urban model, and all sorts of models. In fact, we cover the time scales from a few minutes to years now. Also, we used to do one forecast per event, let's say, but now on a regular basis, we produce 20 forecasts that are slightly different, okay, but that are important to measure the uncertainty of the forecast. Everybody knows that the forecasts are not perfect, but now we provide the uncertainty associated with the forecast by using what we call the ensemble. But that comes to a price. The price is more computation and more volume of output data. And also, finally, we are not only producing weather forecasts, but also ocean forecast, sea ice forecast, land surface forecast, river forecast, and so on. So we have more and more diverse different type of numerical forecasts. So all that contributes to increasing the volume of data. So this is the recent changes from January and last. So this is the different numerical models that has been updated recently. So last week we updated, so we improved a lot of systems, okay? And when you look at the different systems, you see that some are global, so we cover the whole Earth. Some are regional, North America. High resolution means over Canada only. But we have ensembles and deterministic. Deterministic is just one forecast. Ensembles is an ensemble of forecasts for, let's say, same event. We have not only the weather, but we have also air quality. Here we have storm surge, wave model, water cycle, so hydrological system, seasonal forecast system. So you see that the diversity is continuing to increase. What it means is this: there's an exponential growth of our data volume. So before last week, we were at, I think, like something like 10 terabyte 25 terabytes of data output every day, but since last week, we are at 40 terabytes of data each day. Of course, not all of that is made public. It's about 5 to 10%. So the data flow size and the diversity of sources can be overwhelming for users. Like you, let's say you want to use our data, but which one should I use? Okay, I want a temperature forecast. Okay, yes, but you have a global model, you have a regional model, you have a national model, you have ensemble, deterministic. Which temperature forecast I should use? So, and one point important is the volume of data is growing faster compared to the capacity of the bandwidth. The bandwidth over time is increasing, but not enough to take care of all the volume. So that's a challenge for us. And more decision-making systems are fed directly from servers to server. Our server to your server, in the sense that the forecasts are becoming more and more automated without human intervention to modify the forecast. So the number of numerical prediction systems as well as their output variables. So it's not only temperature and humidity. It's all kinds of variables. Okay, it could be temperature at 10 centimeters under the ground. It could be the different size of particles in the cloud and so on. So that combined with our regular version updates of the system can put stress on the user. And sometimes we do so many modifications that we can produce glitches and you will complain about them. And we receive some complaints from time to time. Like last week, we had a lot of changes. And people that are ingesting our data can have some difficulties because we introduced by error some glitches. Okay, so emergent trends. Well, everybody is aware of artificial intelligence is changing the world, okay? By the way, there's an exhibit here at the Center 5. They didn't tell you that, but as a participant, you have a 20% rebate on the human exhibit. And hopefully they will tell us the promo code for that. Okay, so the trend is, and has been for a few years now, is to combine our weather data to different kind of weather of data. For the energy sector, for example, for real-time grid balance. I think this afternoon we have an example of the use of our wind forecast for wind energy forecast. The transportation sector can also use our data for different kind of things, like optimizing the routing of trucks, optimization of snow removal, prediction of flight delays, heavy vehicle wind rollover forecast. Same thing in the health sector, predicting the emergency attendance during cold weather or freezing rain or heat wave, so they can manage the schedule of their staff to be sure there's enough staff at the emergency. Forecast of the municipal sewer overflows and water quality for bathing. In the business sectors, there's many things, okay? For the retailing, let's say, how many steak should I order? Because I know they are predicting a heat wave this weekend, so big chain can manage their stock better. Farming is an important sector that they can use our data in real time also. Okay, so how our dissemination approaches should or could evolve? Well, we believe that we should continue to expand and facilitate access using cost-effective data access approaches like the MSC Data Mart. Sandrine will talk about it. Further develop our web services for dissemination. We'll have a talk on the MSC GeoMet also. Improve and develop web user interfaces for better access user experience. For example, the CCCS portal will have a demonstration on that too this morning. Another trend and how we can maybe get more from our and your data is to put our and your data on the same platform to do data analytics, okay? Not just you taking part of our data, but really putting all our data on the same platform. And we have a research project with IBM for that. And at the end, well, outreach and train users to better access and select the best data for their needs. And this event, the Meteorological event, is, I believe, doing that. So in conclusion, well, the MSC is a large producer of weather and climate, water, air quality, and environmental open data. In fact, we are the largest open data producer of the federal government. The amount and diversity of the MSC data offerings are continuously increasing and posing many challenges. Matching up our data with other sources of data through the use of artificial intelligence algorithms has a promising future. So weather, climate, and water and environmental data is for everybody, so enjoy it. Thank you.
Merci Bertrand.